Go. All right, my next problem is to determine the radius of convergence for the power series represented in this problem. And then I'm going to test the endpoints to determine the intervals of convergence. So as I see x divided by 3 to the k power, I can actually rewrite that problem as this. Okay, so I wrote x, I just rewrote it to x to the k power and 3 to the k power. Therefore, I did that to make it simple because I can test this using the ratio test. So using the ratio test, wherever I see a k, I'm going to put an n plus 1. So I'm going to set my limit as n goes to infinity. So x, and the k will be n plus 1 divided by 3n plus 1. And I'm going to multiply that by the reciprocal of the original problem. Okay, so I have, when I factor that down, so as n goes to infinity, I can go ahead and simplify xn plus 1 divided by xn. That will leave me with just x in my numerator and 3n on top and 3n plus 1. That will leave me a 3 in my denominator. So what we want is our limit to be less than 1. And so to do that, so we're trying to solve 4x, so I'm going to multiply 3 on both sides. So I will have a negative 3 here, and x, and 3. So my endpoints, these will be my endpoints. So in order to test my endpoints to make sure that if they diverge or converge, so x would equal negative 3 over here, x would equal 3, and so as n equals 1, I will have negative 3 over 3. So n equals 1, and so as you can see that negative 1 to the power of 1 would not be 0, so this would diverge. And similarly over here, and as x is in this case 3 and raised to the first power, so that be, so you can also see that this is not 0 either, so this would diverge. So therefore, my interval of convergence would be negative 3, 3. So now I need to find my radius. So I will calculate that by subtracting my y minus my x and dividing that by 2. And so that will equal 6 divided by 2. So my radius will be 3. So my radius is 3 and my interval is negative 3, 3.